Hello, and welcome to this video where we will be continuing our discussion from the previous session where we discussed states. And now we will talk about state transition, how the state transition is achieved, and that is through operators. That is something which we will see in detail in this video. Why do we require state transition? So, for example, you purposefully change the system, or the system get changed automatically by, for example, external noise. Let's depict the straight transition as we can see in this slide. What we see here that each vertex now has an outgoing edge. That is, the aim for us is to transfer all marbles from one vertex to another. And there is a one inbound loopy edge that is coming on the vertex holding one marble as depicted by number 1. How to achieve this state transition? So we are now transferring all the marbles in one edges from 3, and the number of marble from the left topmost is coming to the right bottommost. So you see as depicted here, the right topmost has 8 marbles now, 4 plus 3 plus 1, and the left topmost 5 marbles on the topmost edge is now coming to the right bottom, 5. So that is how this is being pictorially represented. You can also go ahead and write this now in a vector form, which means vector which was initially represented by x0 having 4 vertices with number of marbles in this is now represented by a different state x1 with 8 and 5 marbles on 2 of the vertices, and rest 2 has no marbles because we have transferred them. This can be further extended and be seen as something that there is a transition from x0 to x1 which is accomplished by having a matrices multiply the initial state x0 in a way that it end up resulting in the new state of x1. Now, mathematically, to decipher that, let's give an example. The intuition can be very easy, but also that the knowledge of matrix multiplication plays a major part here. To know more about matrix multiplication, I encourage you to watch videos of quantum linear algebra, the series that I have published before. Now, if you see how the matrix with its values of zeros and 1 end up transitioning x0 to x1, it will be very easy to comprehend. Therefore, in this case, our operator, which is now represented by a matrix, operates on states, which is represented by vectors, and help in transitioning the states from x0 to x1 in this example. What we can learn from this simple example is that the marble distribution over the vectors is a straight described by vector, as also we have seen in the first video of this series. Edges execute state changes, which is accomplished by matrix or operator as we call it. And then with the combination of this with different configuration or different constraint as we say on vectors and matrices, we can govern different mechanics. You may also, for example, end up redistributing the marbles equally on 4 edges instead of just concentrating only on two edges. So this is a simple way of representing how system can be altered, or maybe they get altered on their own with the same mechanism, like a natural matrix is being applied on it by nature, and help in transitioning from one state to another. I'll stop here. Thank you very much for watching, and I'll see you in the next video. Thanks a lot.